At this point, you've probably heard quite a bit about the new heat treating regulations for hardwood pallets. I'd like to spend a little bit of time talking about heat treating methods and talking about schedules and potential for degrade and the amount of time that it takes to heat treat pallet material. And basically, you've probably already covered exactly what the regulations are. As an extension specialist at the University of Tennessee, I got a lot of calls when the information about the new heat treating regulations came out. And the calls basically were asking me, how long will it take to heat treat this hardwood material? How much degrade will occur if we heat treat this material? And we didn't have the answers for those questions, so we set out to do a little pilot project to be able to answer those questions. And so that's basically what I'm going to cover today, are some of the experimental trials that we did using an experimental dry kiln and actually heat treating pallets in that experimental kiln. And again, basically, as I go through the first part of the presentation, we're going to be looking at those experimental results. And so we're going to be looking at, one, how long does it take to treat it? Was there any degrade that occurred? And were there any treating difficulties with the methods that we used? And basically, we looked at that in specific relation to should I build my own kiln? How should I do that? And what would be required? For the specific tests that we did, we looked at the standard stringer pallet. And that's pictured in the slides here. We looked basically at red oak, yellow poplar. We had a little bit of beech and hickory in there, but our predominant species in those pallets was red oak and yellow poplar. We did not look at block-style pallets. We measured the temperature for our treatment process by the use of thermocouples. And we put these thermocouples initially in various places in the pallets before we put them in the kiln. We put them in deck boards, in the stringers, and in different configurations. We tested those configurations to come up with the optimal. And obviously the optimal would, for the heat treatment requirement is what particular location would take the longest to reach the required heat treatment temperature. And that obviously that would be the thickest member, which is the stringer of a pallet. We basically have 3 trials that I'm going to talk about specifically today. Those 3 trials are focused on comparing heat treatment process using strictly heat, and the second is using steam. We use live steam to heat treat the pallet, and we wanted to compare and contrast how fast the heat treatment process would be using these 2 methods of heating. We also did a trial using steam initially and then some dry heat at the end to try and dry the pallet out a little bit. But we'll run through some of those right now. Our first heat treatment trial was using steam heat. We basically turned off any steam, the steam coils in the dry kiln. We used predominantly the steam spray that would be used for conditioning in a standard drying process. We set our temperature to about 160 degrees Fahrenheit. We kept the vents closed so that any moisture in the system stayed in the system. Obviously, we were using saturated steam, so it was 100% humidity. We put thermocouples in the deck boards and in the stringers at different locations and in all the different species that were present in the dry kiln. You can see in the graph here exactly what happened. We reached our set point very quickly, and our set point is our treating temperature. The regulations state that it needs to be 133 degrees Fahrenheit for 30 minutes. Obviously, to get that to happen, to get that material to the required temperature as fast as possible, we used a higher set point. We used about 160 degrees Fahrenheit. We reached that in 17 minutes, and that's one of the limitations of this work, is the fact that in a laboratory kiln, we can reach set point very quickly. We reached it in about 17 minutes. It took us a total of about 32 minutes to treat those, to get those pallets, the center of that pallet, to the required treatment temperature. So a total of about 62 minutes to treat that pallet using a steam process. Now on that graph, you'll notice there's some variation in how quickly those boards, or the thermocouples placed in those boards, heated up. And that's mainly based on the difference in thickness of that material and also the difference in species. Obviously, a denser species took a little bit longer to heat up, and the thicker material obviously heated up a little bit slower. But basically, the entire process is constrained by that material which is hardest to treat. And we were able to do that through the entire process in 62 minutes. So basically, if you look at heat treating pallets in general, you're concerned about how much time it would take. It happens very rapidly in a steam process. One of the other things we were really concerned about is what happens to the moisture content of this material. If you're in the pallet business, you're obviously very interested in keeping the weight of the material to a minimum, yet also not having any degrade occur in the heat treatment process. We were a little concerned that there might be some moisture uptake in a saturated environment when using steam. You can see from our results here that the moisture content change was negligible. There was actually no change in moisture content from before the steam treatment and after steam treatment. So that's a really good thing if you're interested in not having any degrade. Obviously, if there's no moisture content change, there isn't going to be any degrade that occurs because there will be no shrinkage. One of the degrades that might be considered in using a steam heat treatment process would be there was a little bit of discoloration around the nail heads. It was the producers that we worked with said that it was not significant, and this rusting of the nail heads and discoloration did not really occur until after the heat treatment process, once those pallets were taken out of the treatment chamber and allowed to sit for some period of time. And some of that blackening around the nail head is going to occur anyway, even if these pallets are air-dried. That's just a natural chemical occurrence from the extractive that's in oak with the iron that's in steel. And some of the rusting would occur naturally in putting together green pallets in the air-drying process anyway. So it's not really a significant consideration. One of my colleagues looked at treating pallet parts. Joe Denning at NC State took the steaming process one step further. Several folks were interested in focusing in on what if we fill up an entire kiln with parts. And obviously we would get more material in a kiln if we were putting it in there as parts rather than if we were putting intact pallets or assembled pallets in a kiln. So he put in pallets of dead packed pallet parts into a treatment chamber. He set the temperature for 160 degrees Fahrenheit, kept the vents closed, and did the same process of using the steam heat or steam for conditioning to heat those pallet parts up. Very interesting. It took considerably longer to heat treat those pallets, and basically that's because of the heat transfer to get through a dead pack is significant. It takes about 11 to 15 times longer to heat treat dead packed pallet parts. So this kind of indicates that if you're going to be looking at a rapid process and getting a lot of throughput through your kilns in a short period of time and onto trucks, it's probably a little bit, well, it is definitely a much faster process to heat treat the assembled pallets rather than pallet parts. However, one of the concerns of heat treating pallet parts was, if I heat treat those pallet parts and they dry out, will I be able to assemble them because of the moisture loss and the hardening of wood as it dries out? And as we've kind of already shown, that there was no moisture content change in the heat treating process using steam, so that should not be an issue if you're going to heat treat dead packed pallet parts. It will take longer, but you can still assemble those parts into a pallet if you're using the steam heat treatment process. Our next treatment schedule that we used was using directly heat. And so basically we used a dry kiln that used steam and converted that steam heat or steam into direct heat using heating coils. So there was no humidity allowed into the chamber other than the moisture coming off of the wood itself. It took quite a bit longer to do this process. It took about 88 minutes to reach our set point. We did keep our vents closed so that any moisture coming off of the pallets would increase the humidity. We reached about 120 degrees on the wet bulb in the process. That's about a 30% relative humidity. We managed to do the entire treatment process in about 181 minutes. And so while that is about 3 times longer than the steam heating process, that's still a very rapid heat treating process. And we found that even the commercial systems out there can heat treat assembled pallets in about a 3-hour time period. Now that obviously is going to going to be dependent upon the BTUs and of that heating unit, and also what kind of airflow is in there to carry the heat to the pallets. But there are commercial systems that will heat treat using direct heat in about a 3 to 4 hour time period, which goes right along with the results that we found. Moisture content change using direct heat. Now that was a little bit more of a concern than when we used steam heat. However, you can see from our numbers here that there was a very insignificant moisture loss or moisture change from between the initial, before we started that heat treatment process and when we finished that heat treatment process. And that's not real surprising considering how rapid we were able to heat treat those pallets. And again, you can consider that if there's almost no moisture loss that occurs in the heat treating process, there's very little shrinkage of the wood. If there's little shrinkage of the wood, then there's going to be no cracking and splitting that occurs. So really, even a direct heating process with no moisture control or added humidity into the process is not going to significantly add to our D grade. One of the things we were also interested in looking at was what the moisture content differential was between the shell and the core of some of this pallet material to see just how dry the outside would get. And our average moisture content was about 34% in the shell and about 65% in the core. So what that tells us is that we're still above fiber saturation point on the shell, and so that mold will still be an issue because we know that mold will occur on wood above 20% moisture content. So in the direct heat treating process with the times that we're talking about, we may get minimal degrade, but mold after treatment is still an issue. And we'll talk about that in a little more detail here. We measured the moisture content of these pallets after about 21 hours after the heat treating process to see how much moisture would be given off the pallet during what I would call the cool-off phase. And this is kind of important because we had some pallet producers who were actually heat treating material, and to keep that material, quote, sterilized, they had to put the material directly into a tractor trailer after the heat treating process. Now, one of the problems with that is that tractor trailer was obviously closed up to keep that material sterile. Hot, wet wood continues to give off moisture at an accelerated rate. And one of the things they found is they had a considerable amount of mold that occurred on some of those pallets. And that's basically what these results show, is that a significant amount of moisture is given off in a very short period of time. We lost about 16% moisture content in that 20-hour time period. So basically what we're saying is when you pull that material out of a treatment chamber, regardless of the treatment method you use, you need to let those pallets cool in the open air or in a covered shed, somewhere where that moisture can get out and not remain in that pallet or in that area so that you can get molding on the sides of the material. Very important consideration for the grocery industry or medical supply industry who will not accept pallets with mold on them. Now again, the whole heat treatment process, the purpose of it is not to prevent mold, but it's to prevent other organisms from surviving in the transport process of that pallet overseas. And it does a very effective job in doing that, but the problem with mold is mold spores are in the air everywhere, and it's very easy to reinfest treated material with mold. Pallet degrade, I've already kind of alluded to. With no shrinkage, you get no pallet degrade, and that's exactly what we found, very insignificant degrade. No splitting really occurred. We had a little bit of shrinkage around the deck boards, between the deck boards and the stringers. We were assured that this was not a real significant problem. Evidently, if there's no splitting that occurs where you can see the nail or the amount of shrinkage does not expose any of the nail, then it's not a significant strength or degrade problem for the pallet. Our other treatment, heat treatment that we did, we looked at increasing the humidity. We used direct dry heat, but we actually supplied some humidity into that system. We basically raised our wet bulb or increased our humidity to about 62% relative humidity or 160 degrees on the wet bulb. What we were trying to simulate here is, if we use dry heat, like a direct fire dry kiln, and we put in something like a mistifier or some way to add humidity, would that basically speed up the process? Because we know that heat transfers better in a higher humidity environment, which is one of the reasons why direct steam works so well as a heat treatment process. And so we basically raised the humidity and did another dry heat run using the same species and type of pallet. And this was done by my colleague at NC State, Joe Denning. Basically, he did significantly decrease the amount of treatment time that was required. He reduced that from about 188 minutes down to about 85 minutes. So we're getting pretty close to the steam treatment required time. I believe it took us about 62 minutes using direct steam to heat treat that pallet. And here with the higher humidity, we're doing it, higher humidity and temperature, we're doing it in about 85 minutes. One of the final treatments that we did is we looked at trying to reduce this factor of mold, or the potential for mold to grow on a pallet. Again, this is not a requirement of the IPPC regulations, but it was something that our pallet producers were very interested in. We want a heat-treated pallet that won't grow mold when we send it to our customer. And so we looked at trying to treat that pallet for the requirement as fast as possible using the steaming treatment, and then trying to dry that pallet out a little bit so that we had a surface moisture content of about 20%. And what's important is when we talk about preventing mold in pallets or drying pallets out is from a lumber drying perspective. When we talk about drying things out, we think of a 6 to 8% moisture content, because that's the moisture content that material is going to be used. But for pallets, if we're trying to prevent mold, all we really need is a surface moisture content less than 20%, because mold grows on the surface of lumber and requires moisture content 20% or above. So what we really need to do in preventing mold in drying pallets is really, we can have a moisture gradient, significant gradient, as long as our surface moisture content is 20%. So if we average that out, a average moisture content of around 28 to 30% is pretty good standard to shoot for drying pallets to prevent mold. And that's basically what we were trying to do. We were trying to see how rapidly we could do that with one trial. And so we set our dry bulb for about 150 degrees Fahrenheit, a very low, well, initially we did a steaming treatment, so we were at 160 degrees with direct steam. After that pallet was treated in about 60 minutes, we started to pull a drying cycle. So we started to do some venting. And I won't go through the exact schedule here, but you can see on the slide as we started to pull a wider depression to dry that material out. But again, we did this in a fairly quick time period. Our drying time was about 6 hours, 6.5 hours. We were going to see if we could pull that surface moisture content down to below 20%. We were not able to do that with this particular trial. We did manage to lower our moisture content, but we did not get the surface below the 20%. Our average shell or outside material was about 27%, and the core was around 60, with an average moisture content of about 48%. So basically, in 6 hours of drying, in the conditions we used, we just weren't able to get that. And that's not too surprising, because we were also trying to minimize the amount of degrade that would occur. And it's very hard to dry the surface of a dense material like oak out without creating a lot of defects in a short period of time. And basically, if you looked at our pallet treatment, this particular, the steam and heat treatment method, you'll find that we actually had little to no degrade through this process. A couple of comments on kiln drying pallets, which would really be the next step if you were interested in really heat treating to meet the requirements and eliminating mold. The temperatures, typical heat treating temperatures or drying temperatures for drying pallets anywhere from 160 to 180 degrees. And at those temperatures, it's going to take you about 5 to 6 days to dry that pallet down to about an average of 30% moisture content from green. And that's considering that a green oak pallet is going to be upwards around 70 to 80% moisture content green fresh off the saw. And so that's a significant amount of moisture loss to occur even to get us down to that distribution. So with a target of about 5 to 6 days for minimal degrade. We have had lots of producers try to beat that time. And basically what happens is what you see in this particular slide here. With a dense material like red oak, the faster you go with large members, and a pallet stringer is a fairly large member to be drying rapidly, you end up with these splits that you see in the slide here. There's also a significant amount of cupping that occurred in the deck board, pulling away from the stringer. So pretty much unacceptable if you try to go less than a 5-day cycle at 160 to 180 degrees. Some of the limitations of the work that we've been talking about, we did do it in a laboratory kiln, which allowed us to reach set points very quickly. The conditions that we were able to attain would actually be quite a bit more rapid than what you might be able to attain with a commercially purchased system. It depends on the system that you purchase. It all depends on the BTU output of the burner that they have and the air circulation that you have in that kiln. Regardless of which system you get and what you look for, what we basically demonstrated is that with dry heat or with steam heat, you can actually heat treat pallets very rapidly in much less than an 8-hour cycle with minimal degrade, so that you get very little losses without a significant amount of problems that occur. Just to kind of summarize, if you disregard heat up time and how long it takes to heat treat the chamber, steam treatment takes about three times faster than dry heat. One advantage of using direct steam is the fact that there are now schedules published from the Forest Products Lab. Bill Simpson at the Forest Products Lab actually developed some tables, and you can download these off the Forest Products Lab website. For a certain size member with a certain size density and specific gravity, initial temperature, you can look up on a table and it will tell you exactly how long you'll have to be at a certain condition to heat treat that particular member. Very useful publication and information. However, I'm not necessarily recommending steam treatment, and one of the limitations of steam, or one of the problems with steam, is it can be very corrosive, or rather very detrimental to the dry kiln structure or a heat treatment chamber structure. We'll tend to have a fair amount of condensation in the wintertime, particularly if the chamber is not well insulated. Some of these materials that we are heat treating are fairly caustic. Oak tends to produce tannic acid, which has some sulfuric acid in it, which is very detrimental to kiln components. And if you think about dry kilns, one of the times in the drying schedule where we cause the most degrade or detriment to a kiln structure is in the conditioning phase, where we're using live steam or pouring live steam into a chamber. So if you decide to go with the steaming route, while it may be very rapid, it's going to be very hard on your treatment chamber, and also you're going to have tremendous fuel costs. So there's some efficiency issues in using steam. It may actually be more expensive than a direct-fired burner. There's actually some very efficient, fairly inexpensive direct-fired, gas-fired burners on the market currently, which a lot of these commercial heating chambers use. Let's see. Minimal moisture content change, basically using both heat treatment methods, which again relates to minimal amount of degrade, both very rapid heat treating processes. One summary item would be that the higher the humidity is in the drying chamber, the more rapid you can get from the treating process. Not a real big factor because it can be done so quickly. Again, some of the commercial chambers out there state that they can treat in about a 3 to 4 hour cycle. But if you're interested in increasing the humidity, it will give you a faster treatment time. There are all kinds of ways to do that: small boilers, EMC mistifiers that will increase the humidity out in the treatment chamber. Testing difficulties: we've already mentioned the steam problems, problems with using steam in a treatment chamber, degradation to the chamber, fuel cost requirements, the cost of heating it. Also, the fact that when you take that pallet material out of a treatment chamber, you need to let it cool in an environment where the moisture coming out of that material is not going to be able to condense back on the pallet or in the chamber that it's cooling in. Heat treating pallets does not prevent mold. Mold spores are in the air everywhere. That's something you may be considered with, and you may not have to consider. It depends on the industry that you're serving as a pallet producer. Things that you need to consider if you're going to design and build your own heat treatment chamber, or if you're looking for a heat treatment chamber. Heating source. The more BTUs you get output per hour, obviously, the faster you'll heat treat that material. Airflow. Airflow is vital in heat treating pallets. You have to be able to carry the heat produced from the burner to the pallets. So any kind of design that you're looking at, make sure there's sufficient airflow to get the heat to the pallet. Humidity. If you're interested in a more rapid process, humidity will help. It's not necessary. As we've demonstrated, without controlling humidity, you can actually heat treat very rapidly. How you measure the heat treatment temperature is also very important. Depending on the accreditation agency that you're going through, thermocouples are very easy to use. Certain accreditation agencies are going to require thermocouples in certain locations, a certain number of them, but that's something you may also want to consider when you're looking at a heat treatment chamber. Some of them only require control charts showing the wet bulb and dry bulb temperatures. A great deal of them use the thermocouples. Minimal degrade. When we're talking about heat treating and degrade, there's minimal degrade whether you're using steam heat or whether you're using dry heat, basically due to how rapidly the process occurs. I would like to talk a little bit about different types of pallets and degrade. When we talk about this degrade factor, we're focusing mainly on green pallets. That's basically what we tested. With green pallets, since there's no significant moisture loss, we did not see any significant degrade. Some of my colleagues at Virginia Tech also looked at heat treating air-dried pallets and recycled pallets. And when they compared green pallets, air-dried pallets, and recycled pallets through the heat treatment process, they found that the amount of degrade for green and air-dried pallets was insignificant. There was very little degrade that occurred. However, for recycled pallets, or pallets that have been in service for a long period of time, and they typically have a initial moisture content of around 12% since they've been in service, the heat treatment process is actually a little bit detrimental to a recycled pallet. There's just enough moisture loss that occurs. Most of that moisture loss occurs through the end grain very rapidly, and there's some splitting that occurs in the deck boards. And so when they were looking at actual pallet degrade, one of the main key factors they were focusing in on was splits in the deck boards at the nail joint. And if you can't see a nail in the split, then it wasn't considered a defect. And if you could see the nail in the split, then it was considered a defect. And there were a fair number of these splits that occurred in recycled pallets. And so there may be some issues if you're handling recycled pallets of actually having to use some way and some method to put humidity back into that treatment chamber. And recycled pallets are going to be a big issue with heat treating eventually. Probably about a third of the pallets that are put into the system every year are recycled pallets, and that number is expected to grow. So that may be a consideration for your heat treatment chamber. Some of the things that you'll see when you're heat treating this material that are not problems, if you can see on the picture here, you'll see these black stains on the side of the pallet. These black stains are basically interaction that occurs between the tannic acid in oak, or the extractive content in oak, and steel, the iron in steel. It's basically a blackening effect, a chemical reaction that occurs. This is normal. This occurs in all wet green oak that comes in contact with metal bands and strapping. It is not a degrade or a defect. The other thing you'll probably see is some watermarks. And you can see in the center of this pack of pallets, there's what we'll call watermark, water staining. In the treating process, especially if you're using dry heat, there is a little bit of moisture loss. You'll note that it was fairly insignificant. It was fairly small, but there is a little bit of moisture loss. Most of this moisture loss happens at the end grain, which is basically at the end grain of the pallet cant and the pallet deck board. And that's what these watermarks are. This is where free water in the cell lumen in the wood material has actually come out of that pallet very quickly. Water comes out of the end of wood about 10 times faster than it does the other surfaces. And so that water is just run down the end of the pallet. Not a degrade factor. That's not mold. That's just a water stain mark from this water coming out of the wood. Well, with that, that pretty much wraps up my presentation. I hope it was informative. I'd be happy to answer any of your questions. If you contact me directly, there'll be some information. My contact information will be displayed at the end of this presentation. I hope this was very informative, and please contact me if you have any questions. Thank you.